Yeah, all right. Customer. Once again, Aku Jometa. So, Lenny, um, Unit 4. I don't know. Can you hear me now? Let me know if you can hear me now, ma. Ṣé gbọ́ mi, ma? Ṣé ẹ ń gbọ́ mi? Can you hear me? Ah, má tí mi ìdẹ̀ gbọ́n kankan látẹ̀kọ́. Mo ti ń béèrè pé ṣé lè gbọ́ mi láti ẹ̀ẹ̀kan. So, I wasn't very sure if you were still there. Okay. So once again, we are starting with from week Unit 4. Unit 4 sọ̀rọ̀ lórí econometric model, and model sọ pé econometric model pé a ti wà use mọ́ náà tẹ́lẹ̀tẹ́lẹ̀. So econometric model is just talking about those models that we build. Tá a máa fi parameter kan àbí méjì síbẹ̀. Then there was going to be an error term. You are going to have a regressor and a regressand. Like I mean, you are going to have an independent variable and a dependent variable. So reading from 4.1, the introduction. Can you hear me up to this point? Ṣé ẹ gbọ́ mi dé àsìkò yìí? Okay, okay. So from 4.1, the introduction, it says that the basic tool for econometrics is the linear regression model. So linear, an equation is linear. So we're just trying to like say that the highest power of the variable in that equation is raised to power 1. So I'm going to pay equation a linear equation if the highest power of the variable in that equation is raised to power 1. So once the variable bá ti ń ní power tó ju 1 lọ, tó ti ń jọ bí 2 or 3, equation kì í ṣe linear equation mọ́. So the highest power of a linear equation must be 1. So if you have y is equal to 2x plus 1, y is raised to power 1, x is raised to power 1, that's a linear equation. So but if bá ti ní y is equal to 2x squared plus 1, ìyẹn ò kí ń ṣe linear equation mọ́ torí x tí wọ́n á ní power tó ju 1 lọ. So well, that's about that. So the basic tool of econometrics is the linear regression model. Then in modern econometrics, wọ́n máa ń lo other statistical tools. Now oríṣiríṣi ọ̀nà náà ni wọ́n lè oríṣiríṣi method ni a lè lò ní econometrics láti fi wá relationship between one information, one data and another piece of data. But then the common one is the regression, which has been mentioned here. So you have others. I think there was one place I was reading exploratory analysis, and as more projects I think I remember coming across literatures that made use of exploratory, like beginning of exploratory analysis, then maximum likelihood, bẹ́yẹn. But whatever, what we are majorly concerned with is the regression. So kí ni wọ́n ń pè ní regression gangan fúnra rẹ̀ sábẹ́? I want you to like note this down. So regression is the estimation. So I'll put it in the chat box. So regression is the estimation of of the average value of the dependent variable based on the values of the independent variable in repeated sampling. So I'll just send this in the chat box. So it is the estimation of the average value of the dependent variable, okay, based on the values of the based on the values of the independent variables in repeated sampling. So that's the meaning of regression. Now leaving that, Àwa fi kíní kan wà níbí, there is an equation here which is showing the relationship between unemployment and economic growth. Now ó ní theory dẹ̀ mọ̀ pé ìgbà tá ṣe linear method of regression nígbà yẹn we started with you state there's going to be an economic theory, you state the mathematical form of the model, then you state the econometric form of the model, you gather your data, you run your analysis, then you do your interpretation, forecasting, etc like that. So níbí báyìí nísìnyí whenever you have a regression function like this, when you have relationship between unemployment and economic growth, ó ní nǹkan kan tá a máa ń pè é, Okun's law la máa ń pè é, bí okùn ní Yorùbá like okùn for rope, but eléyìí okùn yẹn wá jẹ́ orúkọ ènìyàn, so Okun's law. Now Okun's law ń try sọ fún wa pé relationship wà láàrin economic growth àti level of unemployment, and there is a relationship between economic growth and the level of unemployment in an economy. So how do we measure economic growth? GDP data la máa ń lò. So for us to know if an economy has grown, economic growth is just the increase in the production in a given economy, like the increase in the overall production of a given economy. So and it's measured in terms of GDP. So if the GDP was 1 million in the first quarter of 2024, and then the GDP becomes 2 million in the second quarter of 2024, so 2 million minus 1 million, tabashi change here, that's going to be 100% change. So 31 million double to 2 million, so that's 100% change. So in that case, you will say that the economy is experiencing 100% growth, since the percentage change between the old GDP and the new GDP value is 100%. Now, question to one Ben when the economy is growing, what do you think is happening to unemployment? So like I'm asking you now, I want you to like say something. So what do you think is happening to unemployment when the economy is growing? Hello, ma. I just asked a question. So when the economy is growing, what do you think is going to happen to unemployment? What happens to the unemployment? Tí economy bá ń grow, kí ló máa ṣẹlẹ̀ sí unemployment? Okay. Ó dà pé ẹ̀ ń ṣe ó dà pé ẹ̀ ń ṣe nǹkan mi lọ́wọ́ ń bẹ̀rẹ̀ yẹn. Well, I just want to be sure. Okay, I just want to be sure that you're following. So unemployment is when unemployment is reducing, when economy is growing, unemployment is reducing. So nǹkan tí Okun wan try láti sọ ni pé ó ní there is a definite number, but material yóò sọ débẹ̀ ṣá, but there is a definite number tí Okun sọ tó speculate pé okay tí economy bá ń grow, you be expecting about I think 2 to 4% level of unemployment. So like if the economy should grow to its full employment, right? So the unemployment that you are going to be having in that economy is going to be between 2 and 4%. So it's not as if the unemployment is going to be zero, but the unemployment is going to be small. Anyways, so as the economy is experiencing growth, there is a change in unemployment that we are experiencing. That is, unemployment is going to be reducing, but it's so and on. So if you continue from the second paragraph here, it says Okun's law represents the relationship between GDP growth and the unemployment rate. The fitted line is found using regression analysis. For example, consider Okun's law, which relates GDP growth to unemployment rate. This relationship is represented in a linear regression, where the change in unemployment rate is a function of an intercept, a given value of GDP growth multiplied by a slope coefficient and an error term. So nǹkan tí yẹn sọ ni equation tó kàn rọra kọ síbí ni nǹkan tí gbogbo òyìnbó yẹn sọ. So there is a change in unemployment. Unemployment is the dependent variable here, or the regressand, and it is a linear function because irú linearity tí à ń sọ fún regression line is linearity in parameters. And how many parameters do we have here? We have two, beta naught and beta 1. Those are our parameters. So if you look at it, their highest powers is 1, beta naught is raised to power 1, beta 2 is raised to power 1. So even if the variable is not linear, if you have a non-linear variable, command econometrics. So what we are trying to like, nǹkan tá a máa ń ṣe ni pé okay, there must be linearity in parameters. There must be linearity in parameters. So if B naught, B1, let's say there's a beta 2, there's a beta 3 or whatever, all of those things, their powers must not be more than 1, right? So this equation tí wọ́n kọ síbí now is a linear regression function. How do you know that? Because B naught and B1 are both raised to power 1 alone. So leaving that, change in unemployment is a function of the constant term, is a function of beta 1, which is going to be the slope parameter. Then the variable here is growth, then plus the error term. So our new what is estimation, like a random kind of estimation. The unknown parameters B naught and B1 are estimated to be there is minus 1.77, or when the B1 is estimated to be minus 1.77 and B naught is estimated to be 0.83. So taba two regression line ńkọ́ with the parameters that we already have. So we are going to be having change in unemployment is equal to 0.83 minus 1.77 B1, then growth. Again, if we were to rewrite this equation, so it's going to be beta naught is 0.83, so 0.83, because beta 1 is a negative number, so that's why it becomes a minus 1.77, then growth, then plus the you are not going to be having error time since we already estimated the parameters. Okay. Bẹ́ẹ̀ ló ṣe, but it is clear enough. No, no, the one I'm just talking about, èyí tí ò overlap the èyí tí òun ni èyí tí mi ń sọ̀rọ̀ nípa ẹ̀. There is one in the middle of the text. Change in unemployment equals to B naught plus B1 growth plus E. Ìyẹn wà bẹ́ẹ̀ ní material yẹn bẹ́ẹ̀, like kò. Mo understand the meaning of overlapping that you are mentioning, but there is one of them that is very clear. So ìyẹn lèmi ń sọ̀rọ̀ lé lórí. So proceeding from that, so I said if we were to rewrite this equation, àwọn ò tún kọ, so àwa lè tún kọ. So since they've already gotten the value of beta naught and beta 1, so change in unemployment is going to be 0.83. What's the for any beta naught at 0.83? So 0.83 minus 1.77 growth, and that's it. So the bá fẹ́ interpret the equation here, so it's just trying to like let us know that the 0.83 that we have is just trying to like let us know that if there is no economic growth in the economy, that is if growth is zero, tí ó bá sí economic growth rárá, then we'll be expecting that the change in unemployment in the economy is going to be 0.83%. Tí ó bá sí economic growth rárá, so when your G is zero, when G is zero, G multiplied by B1, ìyẹn máa di zero. So everything on that side becomes zero. So if there is no economic growth at all, we'll be expecting that our change in unemployment will be 0.83%. So explanation ìyẹn nìyẹn. How about the minus 1.77? So reason tó tiẹ̀ fi jẹ́ minus lásán, ó ti ń show wa pé there is a negative relationship between change in unemployment and the economic growth. Ó ti ń show wa níyẹn already. So which is trying to like let us know that if you increase, if the economy grows by 1%, so I want us like focus here. If the economy grows by 1%, right? So kilo máa ṣẹlẹ̀ sí unemployment. The change in unemployment will be minus 1.77%. I don't know if you got that part. If the economy should grow by 1%, the change in unemployment. Yes. Yes. That's whenever there is an increase in economic growth, there will be a decrease in unemployment rate. 0.83 minus 1 point. So I just texted the estimated equation into the chat box. So nǹkan tí minus 1.77 túmọ̀ sí ni pé if the economy is growing, so let's say let's say growth is equal to 1%. 1%. So in this case, change in u will be equal to 0.83 minus 1.77 into bracket 1%. So like normally, um so the change that I experience, what do you call it now? Um what am I even I was trying to like say something now. So we say on average, so the conclusion is going to be on average, bí nǹkan tí bí independent variable bá ṣe ń change, bí regressor bá ṣe ń change, number tó wà lẹ́gbẹ̀ẹ́ like its coefficient, òun ló máa determine nǹkan tó máa padà ṣẹlẹ̀ sí the dependent variable, which is the unemployment rate here. So let me write what I mean very well. So um, on average is very very important too. So whenever you're interpreting an increase in growth by 1% will reduce. Why are we using reduce? Torí minus tó wà níwájú 1.77 will reduce the change in unemployment by 1.77%. So since you already said will reduce, you don't need to say we reduce the change in unemployment by minus 1.77%. Since there's already something we reduce, this is there come okay minus in it. Yes, you understand? But tó bá jẹ́ pé ẹ kàn sọ pé on average an increase in growth by 1% will lead to a minus 1.77% change in unemployment. So, but if you are using the language reduce to show that unemployment might fall, then the number kò gbọdọ̀ jẹ́ minus mọ́. So you just write the number the way it is. So what if our growth was 3%? What if our growth was, so let's say growth, the economy grew by 3%. So kí ló máa ṣẹlẹ̀ sí change in unemployment? So change in unemployment, change in U will be equal to 0.83 minus 1.77 into bracket 3%. Into bracket 3%. So mi ò wo side the 0.83. So what we just have to do here is minus 1.77 times 3. Kí ni answer tó máa fún wa? Ẹ jẹ́ kí n lọ lo calculator. 5.31%. So it simply means that if the economy grows by 3%, the change the unemployment changes, or let me say unemployment reduces by 5.31. You know, what's that about? I think it's 5.31%. So báwo la ṣe gba 5.31? Just multiply minus 1.77 times 3. So a percentage change in economic growth will lead to a 1.77 percentage decrease in unemployment rate, and a 3% change in economic growth will cause a 5.31% decrease in unemployment rate. So like on and on like that. I don't know if you understand what I'm trying to say here. So well, that being said, tá bá padà sí inú nǹkan tán try to explain. So it's the whole thing has been explained here, saying that the unknown parameter B1 estimated here is minus 1.77. I'm back in the material, and B0 is estimated as 0.83. This means that if GDP growth increased by 1 percentage point, The unemployment rate would be predicted to drop by 1.77 points, percentage points. The model could then be tested for statistical significance as to whether so nǹkan tó wá ń sọ níbí báyìí ni pé okay o, is our model true? Like irú ẹ mọ̀ pé a ti sọ rí pé nípa regression you can use a lot of data, different type of data to do what you want to do, and those data will give you different regression functions, different regression lines, right? So by the time you get a model like this, an econometric model like this, that let's say if your number as soon as 0.83 kinikan kinikan, so if you now want to like know, ṣé relationship tá a gbà nínú model inside this our econometric model, like is it true? Like is it something that is reliable that we can depend on? And from there, la máa lọ sí àwọn hypothesis testing, which is not spoken about here yet. So go and do hypothesis testing to check if B naught is indeed 0.83. That is 0.83, like is it only Bashima Krisha, like is it what we are supposed to get? Something like that. Like is that what we are supposed to get? Therefore B1 assumption ni. Alright, mi ti àwọn tí mo ṣáà sọ̀rọ̀ dé gan báyìí. Uh, okay, yeah, exactly. So there's yes, yeah, exactly. So I'm actually hypothesis testing to like know if those values are what we actually supposed to get, right? So um, but then this is not yet time to talk about hypothesis testing. That comes in later chapters. But still, about hypothesis test, there is a way you can mathematically get B naught and B1. So me more, but I think it should come later in this chapter. I'm gonna solve like I'm gonna share calculations there kan. So I'm gonna data. I'm gonna data for unemployment, for example. I'm gonna data from growth. Then I'm gonna have your calculate. I'm gonna look formula. Formula I'm gonna find answer B naught. So then I'm gonna answer B1. So like those are like possible questions that I think a normal what do you call it now an introductory econometrics exam like ask á kàn fill out àwọn data yẹn then you work on it. So tẹ bá ti mọ bọ́n ṣe ń calculate àwọn bíi mean deviation tẹ́lẹ̀tẹ́lẹ̀, àwọn bíi standard deviation, so like those things are not going to be so difficult by the time we get there. So we now have I think that's about that. We now have econometric theory a ti wà ní 4.3. um I don't know if you are also there. So econometric theory. So what is econometric theory? Tí wọ́n padà bèrè ní self-assessment exercise. Kí ni econometric theory? So it is just a theory that uses statistical theory to evaluate and develop econometric methods. So econometric theory just the way bó ṣe wà níbàyìí náà ni bí àgbérùgbésọ̀ kind of a thing. So it is a statistical theory. What are we pè statistical theory? Torí ó máa ń ní error term. Pé ẹ mọ̀ tá a bá ti kọ model ó máa padà ní error term níwájú ẹ̀. So it is a statistical theory to evaluate and develop econometric methods. Finish. So econometricians try to find estimators. Kí làwọn estimators? Àwọn estimators wa òun làwọn parameters yẹn, àwọn B naught àti B1. So sometimes you may have a multiple regression analysis where you have more than B naught and B1. Èèyàn lè ní B naught kó ní B1 kó ní B2. So àwọn B yẹn ló ń pè ní estimators, and then sometimes it may not even be beta, ó lè fún yín as alpha. Mo mọ̀ pé I want to believe that you can recognize alpha if you see it. So ó lè jẹ́ alpha naught, like alpha 0, alpha 1, whatever, like they can just use any sign. So once you just see a symbol, tẹ́ bá ti rí àwọn symbol ẹ máa dá wọn mọ̀ ná, like ẹ máa dá àwọn symbol yẹn mọ̀ tó bá ti fẹ́ ṣe regression. So àwọn lo beta nínú gbogbo nǹkan tá à ń ṣe, nínú gbogbo nǹkan tá à ń kọ́ra wa yìí, but they may not use beta in an exam or maybe in a test or something. So ẹ̀mẹ́wàá ni mo ṣáà ń wo recording yìí ṣá. Mo tún fẹ́ tún wo. Okay. Alright, so econometricians try to find the estimators that have the desirable statistical properties, including now there are properties of OLS estimators that I want us to note. Properties of OLS estimator. Torí OLS, kí ni OLS? Ordinary least squares. OLS means ordinary least squares. OLS means ordinary least squares. So àwọn beta naught, b naught, b1, b2, etc. are called estimators. So oríṣiríṣi method ló wà. So there is OLS estimators. There are other form of estimators, but estimators a máa ń lò jù, at least in this introductory econometrics that I know of, they are the OLS estimators. So why did we choose OLS estimators? Torí gbogbo àwọn estimators wa, they must have a particular set of properties that will make us to like make use of them. So a máa lọ sí what are the desirable properties of regression estimators of regression estimators. So I don't know. Are you following what I'm doing in the chat box, man? Okay. So you have unbiasedness. Unbiasedness. An estimator must be unbiased. Number two, it must be linear. Number three, it must be efficient. And number four, tí mo rí nínú material yìí, consistent. So these are the desirable properties of regression estimator. So you look at unbiasedness, you look at linearity, you look at efficiency. Okay, efficiency go like so unbiasedness, linearity, efficiency, and consistency. So whatever estimator you want to use must have these particular properties. And for unbiasedness, kí ni ìtumọ̀ unbiasedness? So unbiasedness is just saying that the estimator. So unbiasedness states that the estimator must be equal to the true value. The estimator must be equal to the true value. Then for linearity, in the sense that the parameters must be linear. The parameters must be linear. That is, their power must not be more than one. So I would have any beta square, kini kan beta one square, beta naught square, something like that. Just raise power one. That's all. Now for efficiency, ìtumọ̀ efficiency ni pé the efficiency in the sense that the standard error, standard error must be at minimum. Standard error must be at minimum. So kí ni ìtumọ̀ standard error? Now tá bá ṣe tẹ́ bá rántí nígbà tá ṣe consumption, a ṣe example consumption kan ní last, like when we did our class, when we did for a ṣe nínú forecasting tá ṣe ń gbà yẹn pé okay o, I think our model, the model in the text over represented the actual value, like at that particular time, whatever rántí that particular example. So wọ́n ṣe consumption and GDP or something. Do you remember it? Actually, consumption and GDP or something like that. They were trying to like forecast that okay, if the GDP is this amount, what is the consumption value going to be in year 1997 or something? Other gba number kan 400 and something billion. Then by the time they got into that, exactly. So that stuff that ṣe mi bẹ̀yẹn pé nígbà tí wọ́n ṣe regression, ìyẹn wá padà rí pé okay, overestimate the true value. That is, by the time they got to that particular year, what the regression gave was about 29 billion more than what the actual result was. So irú yẹn sì standard error wà bẹ́ẹ̀, like kí ni ìtumọ̀ standard error? Difference tó wà láàrin true value àti estimated value. So if you can understand it like that, the difference between the true value and the estimated value. So in that case, like I can say that the standard error is 29 billion. So whatever, but that's not the exact way it works. But like for us to just kind of have like an understanding of bó tiẹ̀ ṣe máa ń rí, so mo ṣe like fi ṣàlàyé bẹ́ẹ̀ yẹn. So now if you have different methods of checking it. So if you have different methods of estimation, if you have different methods of estimation, so èyí tó máa fún yín ní the smallest standard error òun lẹ̀ ń wá. So the one that gives the smallest standard error is the efficient one. So that ìtumọ̀ efficiency láàrin àwọn estimators there. So when you say that a parameter or an estimator must be efficient, you are saying that the standard error must be the least across different type of estimators you are using. So we have the OLS, estimators of the OLS, then we have estimators of like other methods. So but OLS la máa ń lò jù nítorí pé the standard error of the OLS is the least compared to other ones that you may want to be using. Now, kí ni ìtumọ̀ consistency? So consistency, all these things are in the material. Well, maybe not all, but at least they are significant in the material. So but consistency, ìyẹn túmọ̀ sí pé ìmọ̀ọ́ṣẹ́ ló wà náà. Abẹ́ econometrics, okay. The larger the sample size, got the consistency try sọ ni pé the larger the sample size, the closer is the estimator to the true value. So that is to say that irú ibi tí ó wà ní material under econometric theory ló wà. It is there. S- Is the material says it is consistent if it converges to the true value as the sample size gets larger. So that's what I'm trying to explain. So like the more the sample size, the more accurately your parameter is going to be, like compared to what you are supposed to have in the real world. So continue entrance is on here. So that's why tí ẹ bá fẹ́ ṣe analysis, wọ́n máa fẹ́ kí èèyàn lo data tó pọ̀. Because tí ẹ bá lo data kékeré, you can lo data bíi 5 years, your results might not be representative of what is out there, like in the real world. So we believe that, or it is believed that the more the data you are using, right? So the better or the more accurate your estimators would be. So continue consistent strategy sọ nìyẹn. So bí data bá ṣe ń pọ̀ sí, bó bá ṣe ń pọ̀ sí, I might expect pé ó yẹ kí parameter yẹn kó máa tend towards what's the true value. True value is like the actual value of that thing in the real world. So nǹkan tó ń try àti pè ní true value nìyẹn. So if you expect that ẹ mọ̀ pé estimation là ń ṣe. Ìyàtọ̀ tó wà nínú true value àti estimated value ni pé you are going to get a true value if you use all the data sets on the, of a particular variable to run an analysis. Bí ẹ fẹ́ ṣe nǹkan kan lórí civil servants ní Nàìjíríà, ẹ bá gba bóyá on civil servants income and their consumption patterns. So if you are able to get all the data of all the civil servants income in Nigeria right now, and you are able to get the data of all of their consumption right now, tẹ́ bá ṣe regression ẹ̀, nǹkan tẹ́ bá ń gbà, àwọn estimators yín, nǹkan tí b naught àti b1 yín máa jẹ́, they are going to be the true value because you used all the data sets that you were supposed to use to carry out that research. But the thing is that in the real, like realistically, tí wọ́n bá fẹ́ ṣe irú analysis bẹ́ẹ̀, you are likely not going to have access to all the civil servants income data. Even if you do, you are likely not going to have all the data sets of all their consumption patterns. Èèyàn mélòó tiẹ̀ ló record the consumption wọn? Táwa kàn máa feel pé wò tá bá ti ná, a ti ná náà nìyẹn, k'Ọlọ́run ṣáà máa pèsè. So èèyàn mélòó ló ń document pé okay, this is what I am actually spending. So at the end of the day, tí èèyàn bá fẹ́ carry out research, sample ló máa ń lò, and sample is an abstraction from the population. So if you use all the data to carry out your analysis, so we say that you use the population. So like language tí statistics máa ń lò fún ẹ, that you use the population. But tó bá jẹ́ pé a part of the population yẹn lẹ lò, a máa sọ pé you used a sample. Ẹ dẹ̀ mọ̀ pé tẹ́ bá fẹ́ ṣe analysis civil servant ní Nàìjíríà, àwọn kan wà tó jẹ́ pé sample tí wọ́n máa lò, data tó máa lò, data ti Ogun State ni. So that's a sample. Ẹlòmíì máa lo data ti Ọ̀ṣun State, ẹlòmíì máa lo data ti Ọ̀yọ́ State, ẹlòmíì máa lo data ti Lagos State. Those are different samples from the entire population of civil servants. So as a result of that, oníkálukú máa gba different regression model So by the time tá bá estimate gbogbo regression wọn, b naught àti b one wọn máa yàtọ̀ síra wọn. Nǹkan tí wọ́n dẹ̀ ń try láti ṣe ni pé wọ́n try láti estimate behaviour consumption àwọn civil servants based on sample táwọn kan rọra ń lò from each of their states. As you understand bẹ́ẹ̀ yẹn. So having a true value or having an estimated value is just trying to like tell you that it's just trying to like let us know in regression analysis that gbogbo nǹkan tá a bá ń ṣe ni pé gbogbo nǹkan tá a bá ń ṣe, the more the sample size, the more data you are using to carry out your research, bó bá ṣe ṣáà ń tóbi sí tó ń tóbi, because bó bá ṣe ń pọ̀ sí ló ṣe máa súnmọ́ nǹkan tí population yẹn jẹ́ gangan. Population is like 36 states in Nigeria, civil servants in 36 states in Nigeria. Tẹ́ bá lo civil servants in one state, your results when you use civil servants in 7 states should be better than when you use civil servants in one state. Your results when you use civil servants in like 12 states should be closer to the actual result of civil servants in 36 states. So government central is on pé you have your estimators are going to be consistent if the larger the sample size you are using, the closer it is, the closer your estimator is to the true value. So we must ever get to like part yẹn pẹ̀lú mo ṣáà ṣe try láti explain it. Alright. So gbogbo àwọn kíni ló ní bó ṣe ń solve wọn, but I don't think it is the business of this particular course. Ó ní bẹ́ẹ̀ ṣe máa ṣe equation lóríṣiríṣi. So anyway, a way to summarize, okay, before even continuing that, lẹ́yìn ibi tí consistency wà, then we now have ordinary least squares is often used for estimation since it provides um, the blue words. Since it provides the blue, anyway, we use the OLS because ó meet gbogbo àwọn condition tí mo ti ṣàlàyé, gbogbo àwọn properties tí mo ti ṣàlàyé yẹn: consistency, efficiency, linearity and unbiasedness. So we call it blue. So OLS estimators are called blue estimators. So B yẹn stand fún best. So like it is actually best linear unbiased estimator. Best linear unbiased estimator, only blue. So it's a way to remember. So the basic properties of OLS estimators, so they are blue. So best is just talking about the efficiency. Because the best in so on, okay, the value that you get for your estimator is the standard error is small, right, between that value and the true value of the estimator. Then linear in the sense that the highest power of the estimators is raised to power 1. Then unbiasedness in the sense that the value that you get is representative of the true value. So and then estimator, like that's just like normal like estimators. So BLUE. So in this place, well, I won't include the consistency, but I think it should just be at the back of our minds. Now when you are asked like explain why the OLS is preferred to other estimation techniques, why is it preferred? It is preferred because of the following properties. It is best, and best you mean it is efficient, and by efficiency you are trying to say that this and this and this. Then 2, it is linear. So why is it linear? This and this and this. Number 3, it is unbiased. So why is it unbiased? Emma Shalaye, no. Then number 4, it is consistent. Why is it consistent? The larger the sample size, the smaller the larger the sample size, the closer the estimator is to the true value, right? And so that's just that. So gbogbo àwọn kíní náà tún pè ní Gauss Markov assumptions. Over in the material, I don't know if you've seen it, the Gauss Markov assumption. So if you ask like state no, sorry. We're going to open the Gauss Markov assumptions. That one is, we'll do that one later. So OLS estimators are blue, given the Gauss Markov assumption. So our assumptions are no autocorrelation, no multicollinearity, like that. All right. Reading on, when these assumptions are violated, well, that kind of assumption any by yet when they are violated or other statistical properties are desired, other estimations such as maximum likelihood estimation. So apart from the OLS, the ordinary least squares, there's another type of estimation technique. Yẹn ló ń pè ní maximum likelihood estimation. So òun náà ní òun náà ní àwọn estimators lọ́dọ̀ títí ẹ̀ náà tó yàtọ̀ sí títí OLS. B naught and B1 títí ẹ̀ òun náà ní, but they have their own properties that are different from the properties of the OLS. Then we have another type of estimator, which is the one that you derive from the general method of movement. So general method of movement is also another name. Then you have another one talking about generalized least squares, GLS, generalized least squares. So àwọn kíní yìí oríṣiríṣi estimation technique ni wọ́n, but the one that is preferred is the ordinary least squares. And why is it preferred? Because of the blue properties. Because of the blue properties. So estimators that incorporate prior beliefs are advocated by those who favor story like Buhari. So we can just go into what is econometric theory? That's a self-assessment exercise. So how would you explain it? Yeah, yeah. No, kò tó yẹn. It's just the first line. No, no, it's just the first line. So econometric theory uses statistical theory to evaluate and develop econometric methods. So it's just you building up a model to discuss an economic theory. That's it. But like I think there is they answered it. Um, they answered it somewhere. Let me see. Okay. Oh, oh, kì í ṣe àwọn eh, okay. Oh, okay. Okay. So I think we are done with. Well, I suppose like just go over it because I thought I saw it somewhere. See, it's in Barry. Well, it's not here again. Maybe on economy. Anyway, that's about that, Sha. So econometric theory is just a statistical theory. So essentially, ṣàlàyé ẹ̀ bẹ́ẹ̀, a statistical theory that is built to explain economic phenomena. A statistical theory that is used to like explain an economic phenomena. So if we prove economic phenomena, if we disprove it or something like that. But it's a statistical theory. Why we are putting statistical is because it is a function of chance, like over probabilistic. So it's not as if this is what is definitely going to happen. It is under probability. So tell us you are important to include statistical theory in your definition of an econometric theory. Okay, so we now have econometric methods, oríṣiríṣi methods tí a lè lò. So applied econometrics uses, I don't know, tẹ́ bá wà ní page 42 pẹ̀lú mi mà. Are you there? Okay, okay. So applied econometrics uses theoretical econometrics and real world data. A ti ṣe types of econometrics sẹ́yìn, that's theoretical econometrics àti applied econometrics. Na theoretical econometrics ó máa ń jẹ́ like the work it does is to build econometric models that then can be used in real world analysis, and there are different parts, whether they're in business, in governments, and whatever. So it just helps to build up econometric methods and then and techniques that can be applied. And then ìgbà tá a bẹ̀rẹ̀ sí sọ̀rọ̀ lórí applied econometrics, ìyẹn òun tiẹ̀ ó máa mú method tí theoretical econometrics ti build á mú lò, then ó máa fi data á apply data lórí ẹ̀. So irinṣẹ́ ni theoretical econometrics máa ń build, applied econometrics máa ń lo irinṣẹ́ yẹn in combination with real world data. That's the same that it just repeated here. Applied econometrics uses theoretical econometrics and real world data for assessing economic theories, developing econometric models, analyze economic history, forecasting, whatever. So continuing from there, it says econometrics may use standard statistical models to study economic questions, but most often they are with observational data rather than in controlled experiments. Now, the issue here is that with economics, emo, taba fẹ́ ṣe bí a fẹ́ postulate a theory kan whatever, àwọn ò dàbí àwọn scientists, I think, which is why we say economics is a social science. You're not like scientists, talk about chlorine àbí tó máa da sodium pọ̀ tó máa dà á mọ́ chlorine tó dẹ̀ máa fún ọ ní salt in a controlled environment like in a laboratory where they can adjust the temperature, they can adjust the humidity, they can do whatever they want to do. But in economics, being a social science something, we've said it before that the whole world is our own laboratory. So and you cannot, there's an extent to which you can control people. You only behave in different ways under the same conditions. You must ever agree. Ṣé wàá ń bẹ̀ mọ́? I can't hear you again. Are you there? Hello. All right, ṣé ẹ log out ni? Okay, me mọ̀ but ìgbà tẹ́ ti padà text me, so I wanted to continue. Máa rí pé èmi nìkan mo wà níbí. All right, so I was trying to explain something to Kini. Okay, share record. So econometrics uses standard statistical models to study economic questions, but most often so I was trying to explain the observational data part. Ipe, we have to like rely on data and data gotten from people. So unlike the way we just work in a controlled laboratory, one scientist share, one is not like that. So observational data in the sense that you need to observe people to get data from them. So in this, the design of observational studies in econometrics is similar to the design of studies in observational disciplines such as whatever, whatever. Now, analysis of data from an observational study is guided by the study protocol. I need to go here. So let's just come to the next paragraph, which says one of the fundamental statistical methods used by econometricians is regression analysis. So regression methods are important in econometrics because economists typically cannot use controlled experiments. So I'm already describe regression for you already. So what did I even call it? The kini mo ti ẹ pinnu ṣe rántí, I think I left it in the chat box. Regression analysis mo ti describe regression analysis láti bẹ̀rẹ̀ lẹ́nu. All right, ẹ má worry, ó ti dá, thank you. Yeah, ó ti wà okay, ó ti wà okay. Estimation of the average value of the dependent variable or the regressant. So average value or the mean value. So mean is same as average. When you find the mean of something, find the average of something. Kankan náà ni. All right. So um, econometricians often seek eliminating natural experiments in the absence of evidence from control, whatever. Anyway, examples of relationships in econometrics. So eléyìí náà dàbí èyí tá a ṣẹ̀ṣẹ̀ ṣàlàyé lórí Okun's law. They are just giving us a new one. So the lean of wage, lean, of course, you are going to know what lean is. is B naught plus B1 years of education. So they are trying to like explain the relationship between wages and years of education. So nǹkan tí wọ́n try láti wò níbí ni pé okay tí education bá is it like does wage increase or decrease with changing levels of education? So does it make sense to acquire more education or to acquire less education or to not even acquire education at all? So this is an example of an econometric model. Now, one of these examples, this example assumes that the natural logarithm of a person's wage, which is a lin, is a linear function. Linear, why is it linear? Share not why to feel linear be by here again. Which of the power? Is it the power of wage or the power of education or the power of B1 or B naught? Power ibo gangan la sọ ńbẹ̀. I told you then that the power of the parameters, like what is important is linearity in parameters. Kí làwọn parameters tó wà níbí báyìí? Linearity, linear àti ity, linearity in parameters. Mo ní kí làwọn parameters tó wà nínú equation yìí? Kí làwọn parameters tó wà nínú equation tó wà níbí báyìí? Years of education is an independent variable. Wage is dependent variable. E is 0 10. Parameter tó wà níbí báyìí is just B naught and B1. I said parameters are the B naught and the B1. Yes. Uh, yeah, that's true. That's correct, man. That's correct. Yes. So independence, years of education ìkan independence in bí báyìí o. Yeah, that's the variable. Beta not at the beta or kì variable. Like you cannot collect data on B naught and B1. It doesn't make meaning. But you can collect data on years of education. So years of education is a variable. Wage is a variable. So wage is a dependent variable in this place. Years of education is an independent variable. Beta not beta one àwọn kì variable. Independent variable, not a regressor. We mentioned him before in one of our classes. Okay. Yes. Yeah. Synonyms. They are synonyms. Mi ì tiẹ̀ rántí. Ẹ má worry, ẹ̀yin náà ẹ máa bọ́nu course ọ̀hún. Ẹ pẹ̀lẹ́. Yes, 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 yes. But, well, yes. Exactly. What I think pé wọ́n ní constant parameter ni wọ́n, but B naught is a constant parameter. B1 is the slope parameter. Tẹ́ bá ṣe y is equal to mx plus c, ẹ máa rí pé B1 ní òun ní m, òun ní slope. Exactly. All right, so the Mongoma, I mean, say rántí mọ́, I think, but if I remember, I think I was asking pé èwo ni parameters nínú equation yìí. Ṣé o ti wá yé yín báyìí? Exactly, our parameter tó wà ń bẹ̀ nìyẹn. Error term ò sí ń bẹ̀ o. Just b gbogbo ètò bá ṣàti dáhùn gbogbo àwọn b naught b1 b2 tí equation yẹn bá gùn jù bẹ́ẹ̀ lọ gbogbo àwọn tó ṣàwà gbogbo àwọn kinní tó wà lẹ́gbẹ̀ẹ́ variable gbogbo àwọn letter tó wà lẹ́gbẹ̀ẹ́ variable plus the constant letter b naught níbí báyìí òun constant equation mi ẹ̀ lè ní alpha naught ó lè jẹ́ alpha naught ó lè jẹ́ alpha 1 ló máa wà ń bẹ̀ tó kàn máa dá dúró then àwọn tó kù máa ní variable lẹ́gbẹ̀ẹ́gbẹ́ wọn so èyí tó dá dúró yẹn àti èyí tó dúró sẹ́gbẹ̀ẹ́ àwọn variables yìí gbogbo wọn bẹ́ẹ̀ ni parameter. Jẹ́ tún wo kinní yìí o. Okay. So continuing jẹ́jẹ́jẹ́ ni econometrics kan náà ṣàánú. I'm coming. Okay, so continuing from there, only this example assumes that the natural log of a person's wage is a linear function of the number of years of education that the person has acquired. Now the parameter B1 measures the increase in natural log of the wage attributable to one more year of education. And the term E is a random variable representing all other factors that may have direct influence on wage. Mo rò pé ẹ rántí yẹn àbí iṣẹ́ tẹ́rọ tẹ̀ máa ń ṣe. Then the econometric goal is to estimate the parameters B0 and B1 in the econometric goal under specific assumptions about the random variable. Now, for example, if this should be wage, so like what skip if wage is uncorrelated with years of education, then the equation can be estimated with ordinary least squares. So tí kò bá sí uncorrelated tí wọ́n sọ yẹn tí ò bá sí nǹkan tó ń pè ní autocorrelation nìkan tí wọ́n try to explain bẹ́ẹ̀ yẹn. Or is it even autocorrelation? No, that should be multicollinearity. Let me like put it in the chat box. Multicollinearity. So if there is multicollinearity, the independent variables will explain themselves. That is, an independent variable will be a linear function of another independent variable. If there's multicollinearity, the dependent variables will explain themselves. That is, an independent variable will be a linear function of another independent variable. So what that sọ ni pé tẹ bá fẹ́ ṣe regression, gbogbo àwọn independent variables tẹ fẹ́ lò wọn ò gbúdọ̀ jẹ́ ìkankan náà. For example, nsìn ẹ fẹ́ ṣe impact of education on wage. So wage is the dependent variable. Ẹ wá ní wage is equal to beta naught plus beta one primary education plus beta two secondary education plus beta three tertiary education. Now gbogbo education tẹ kó pọ̀ ẹ̀, gbogbo stages of education tẹ kó pọ̀ ẹ̀ kò necessary. It is just better to have just said wage is equal to beta naught plus beta one education. Ṣé understand ma? Torí èmi ni primary, èmi ni tertiary education ti ní méjì nínú, ó ti ní primary education nínú, ó ti ní secondary education nínú. So what are you now trying to say? So it is either you just write education or bóyá kí ẹ ṣe wọ́n lẹ́ẹ̀kọ̀ọ̀kan, ẹ kàn máa ṣe okay beta naught plus beta one primary education kó dẹ̀ pé ibi tó máa tán sí nìyẹn. Or bóyá kí ẹ ṣe another model beta naught plus beta one secondary education or another one beta then tertiary education. So like èèyàn nídìí gbogbo kí ló ti ń pe orúkọ ẹ̀ gbogbo dribble pé okay o primary education secondary education pípẹ́ ẹ̀ ń tún nǹkan sọ in different ways nìyẹn. So irú nǹkan bẹ́ẹ̀ kò yẹ kó máa wà tí èèyàn bá ṣe regression analysis. So that's just what they are just trying to explain here, that once you've established that there is no multicollinearity pé kò sí ohun dànù mo tẹ̀ ti rí lẹ́ẹ̀kan náà. So once you have established that there is uncorrelation between years of education, so then the equation can be estimated using ordinary least squares. So I don't know why they didn't talk about the assumptions of OLS. So I think I will share you. Let me share you a video of that. Before I forget, assumptions of the OLS. Mumbo. Okay, this is number one. Èyí tó bá ṣáà ti yé yín bẹ́ẹ̀ ni kẹ́ mú. So they were meant to talk about this one first before even talking about gbogbo eléyìí tá a máa sọ lẹ́yìn, so that ó tiẹ̀ máa yéèyàn nǹkan téèyàn tiẹ̀ ń sọ ó tiẹ̀ máa yéèyàn. This is the first one. Okay, so let me check this recording again. Yeah, mo ti check ẹ. Ó ti dá. All right. So if where are we? Okay. If the researcher could randomly assign people to different levels of education, data set thus generated would allow the blah blah blah. The most obvious third paragraph. The most obvious way to control for birthplace is okay, yeah. They mentioned something important in the second paragraph, so let us just go through it. If the researcher could answer lórí uncorrelation, so tí o bá wà correlated, like that is you can't pinpoint a clear linear relationship between the two variables that you are using. So you can't say okay bóyá ṣàlàyé ẹ̀gọ́ mi báyìí gan, I don't think it is really okay. But what I'm just trying to say is that years of education, then there should be another independent variable, which is an example of another independent variable tí wọ́n mention ní birthplace, like ibi tí wọ́n bíyàn sí. So ibi tí wọ́n bíyàn sí, like does it have implications on the wage tẹ́ni ẹ máa receive? So I don't know, do you think it might probably mean a thing like ibi tó bíyàn sí, like do you think it might affect the kind of wage or salary that an individual might receive? from working. Okay. So ẹni tó bá okay. All right. Okay, so ẹ̀yin fi pé kò sí relationship láàrin kí ló ń porúkọ ẹ̀? Kò sí relationship láàrin ibi tí wọ́n bí èèyàn sí àti iye owó tí ó máa máa gbà tó bá ti bẹ̀rẹ̀ iṣẹ́. Ẹni tó bá bí sí Lekki ńsìn àti ẹni tó bí sí no, okay, àwọn ní highbrow areas ní ọ̀dọ̀ yín l'Ọ̀ṣun State, àwọn bí ẹni tó bá bí sí Governor's House for example ńsìn àti ẹni tí wọ́n bí sí àwọn local areas. So ẹ fi pé kò lè ní implication on the kind of wage tí wọ́n máa gbà lọ́jọ́ iwájú. Well, yeah, I like actually I like your observation, ma. I like your observation. So, but that's a very good observation. So to be very sure of that, bóyá relationship wà, a máa láti wá gba data lórí ibi tó bí àwọn èèyàn sí àti irú owó tó ń gbà. A lè fi mọ̀ bóyá ó ní implication lóòótọ́ àbí kò ní. Anyways, coming to the second paragraph, it says, if the researcher could randomly assign people to different levels of education, the data set thus generated would allow estimation of the effects of changes in years clinical. But in reality, ẹ kò lè assign a value fún level of education àwọn èèyàn. So those experiments cannot be conducted. Instead, the econometrician will observe the years of education and the wages paid to people who differ along many dimensions. So ẹni tó bá fẹ́ ṣe research báyìí, a wá máa study years of schooling àwọn èèyàn. Ọdún mélòó làwọn ẹni báyìí báyìí lò níbi iṣẹ́, èló ni wọ́n ń gbà. So a wá máa gba data lórí. Well, kíláàsì gan máa rush ẹ̀ ní, so nǹkan tí èèyàn bá lè rí bẹ́ẹ̀ ló máa rí. Or we manage to see it through. All right. So I was talking about kí lẹ sọ ma? Oh, okay. Ṣé material mi máa wà lẹ́yìn eléyìí ni? Àbí material náà ni ẹ máa lò all through? Okay. So we have ó ṣáà ní nǹkan tí mo fẹ́ wò níbí báyìí. Okay, let me see. If the researcher could randomly assign people to different levels of education, the data set thus generated would allow estimation of the effect of changes in years of whatever. In reality, those expectations are not clinical. Given this kind of data, the estimated coefficient on years of education in the equation above reflects both the effect of education on wages and effect of other variables on wages. If those other variables were correlated with education, for example, people born in a certain place may have higher wages. Ṣé ẹ̀ ń gbọ́ mi báyìí? Okay. People born in a certain is it people born in a certain place may have higher wages and higher levels of education. Unless the econometrician controls for place of birth in the above equation, the effect of birthplace on wages may be falsely attributed to the effect of education on wages. So, ẹ wá wo ibi tí multicollinearity lè wá wà, in the sense that um ibi tí wọ́n bí èèyàn sí ó lè ní ipa lórí iye owó oṣù tí èèyàn máa gbà níbi iṣẹ́. Báwo ló dẹ̀ ṣe lè ní ipa? Ipa ẹ̀ ni pé èèyàn tí wọ́n bí sí àwùjọ ṣé àwùjọ gidi mo fẹ́ pè ní or something like that, ẹni yẹn máa ní access to a better kind of education, and so the better education will give the person access to better wages in the future. Ẹni tó bá bí sí rural area, access to education ẹ̀ kò lè jẹ́ the same thing pẹ̀lú access to education ẹ̀ tí wọ́n bí sí city. Ṣé ẹ ti rí bó ṣe work bẹ́ẹ̀ yẹn? So I want to say, although people can move from one place to another, but assuming that you stay where you are without you are not assumption máa ń wà, obviously rural area then ibẹ̀ ló dàgbà sí, ibẹ̀ ló ti ṣe school whatever like that, ó dẹ̀ padà ríṣẹ́, then wọ́n bí èèyàn sí city, ibẹ̀ ló ti ṣe school and all of that, ó dẹ̀ ríṣẹ́ náà síbẹ̀. So trying to explain that ibi tí wọ́n bí èèyàn sí máa affect ó máa affect resources tí èèyàn lè fi build ara ẹ̀, and resources yẹn ó máa jẹ́ kí àwọn èèyàn tún dá yàtọ̀ láàárín irú iṣẹ́ tí wọ́n lè yàn láàyò gan, and then the corresponding amount of money that they are going to be like earning at the end of the day. So nǹkan tí bàbá try sọ ni pé tí statistician yẹn tí ò bá fi ara balẹ̀, ó kàn máa sọ pé bá ipa tí education ní lórí iye táwọn èèyàn ń gbà òun ni eléyìí, láì wo ipa tí ibi tí wọ́n bí àwọn èèyàn gan sí, bí ẹ ṣe kọ́kọ́ ní ipa lórí education àwọn èèyàn yẹn then before the wages that they earn. So if the person just looks at education of people generally, ó máa ma over exaggerate importance of education on wages without considering another important variable, which is the birthplace of these people. Ẹ mọ̀ pé quality of education yàtọ̀. Alright, so one of the things tó máa determine quality of education àwọn èèyàn, irú ìdílé tí wọ́n bí sí, then agbègbè tí wọ́n bí sí náà, irú ilé ìwé wo ló lọ and everything like that. So those things would also like have impact on the education. So if a researcher can separate it, okay, this is the part that is due to the birth, this is the part that is due to like education tẹ́ni yẹn ní access sí, then the combined impact òun ló affect which tẹ́ni yẹn gbà in this particular way. So it is important for a researcher to be able to like break things down and understand that okay, bí variable by bó ṣe affect the dependent variable eléyìí òun lélẹ̀ ṣá. That's what they are just trying to like say in that place, that there might be other variables that correlate with education. So for example, people born in certain places may have higher wages and higher levels of education. Unless the econometrician controls for place of birth in the above equation, that is making the place of birth constant. So òun wo education but wá jẹ́ kí place of birth wà constant, although except you can control for that, the effect of birthplace on wages may be falsely attributed to the effect of education on wages. So ipa tí ibi tí wọ́n bí èèyàn sí tó ní lórí iye tẹ́ni yẹn ń gbà lówó oṣù at the end of the day, èèyàn lè assign it incorrectly to ipa tí education èèyàn ní on wages téèyàn ń gbà. So the most obvious way to control for birthplace is to include a measure of the effect of birthplace in the equation above. So which is to tell you that equation tó wà by is not enough. So having just B0 plus B1 years of education is not enough. So if there's another important variable, which is the most obvious way to control for birthplace, is to include a measure of the effect of birthplace in the equation above. Exclusion of birthplace, together with the assumption that error term is uncorrelated with education, produces a misspecified model. Kí ni misspecified model? Model tí èèyàn ń lò tí kò contain iye variable tó yẹ kó contain, iye important variables tó yẹ kó contain. So I already like save that somewhere. I think I can just forward it to you. Okay, no, òun kọ́ ni mo okay, òun kọ́ ni mo save, òun kọ́ ni mo save. But then just know that a misspecified model is a model that does not contain the accurate number of independent variables in the model. The- Ṣé fẹ́ sọ̀rọ̀ kan bẹ́ẹ̀ ni? Okay. Then a model could also be misspecified tó bá pé variable tí ẹ fi síbẹ̀ kò yẹ kó wà níbẹ̀. So tá bá kàn sọ pé kéèyàn kàn misspecify nǹkan like ẹ mọ̀ kéèyàn kàn like ṣe nǹkan in an abnormal way, like that's just what misspecification is normally. And models can be misspecified in various ways, right? So you can misspecify them in the form of variable tó yẹ kó wà níbẹ̀ ó fi síbẹ̀, ìyẹn number one. Number two, variable tí ò yẹ kó wà níbẹ̀ ó fi síbẹ̀. That's another misspecification that somebody may have. Then number three, bó ṣe yẹ kó ṣe kọ equation yẹn kọ́ ló ṣe kọ́. So bóyá wage nísìnyí, bóyá ó yẹ kí wage ní square. So that's also a misspecification of model. Bóyá ó yẹ kó jẹ́ lean wage square equals to beta naught plus beta one education then plus error term. So those are téèyàn ò bá tó jẹ́ pé nǹkan tó yẹ kéèyàn ṣe nìyẹn téèyàn ò wá ṣe tí ò fi square yẹn síbi tí wage wà, then you have also misspecified the model. So this phrase is just trying to tell us pé ẹni tí ó bá ń ṣe research tó dẹ̀ jẹ́ pé in the actual sense of it kì í ṣe education nìkan ni strong determinant of wages, there is another determinant which is your birthplace, and you did not m- make allowance for birthplace in your model, then you are going to be having a misspecified model. And once you have misspecified your model, gbogbo conclusion tẹ́ bá ń draw out from that model is not going to be true. So ibi tí danger ẹ wà nìyẹn. Bí ẹni tó ṣe oògùn ni fún àìsàn tó ṣe tó wrong, kò lè cure àìsàn bó tiẹ̀ wù ẹ́ kó sọ pé kó wá lò ó lẹ́ẹ̀kan láàárọ̀, ẹ̀ẹ̀kan lọ́sàn-án, ẹ̀ẹ̀kan lálẹ́, as long as the drug is already wrong, like it's already fake or whatever, it cannot cure whatever it wants it to cure. It doesn't matter what the patient does. Now, I think there is that chapter equal that chapter mideni. Another technique is to include in the equation additional set of measured covariates which are not instrumental variables. Yes, render B1 identifiable. So I want to believe that what they're trying to say here is that you should also like when you are performing a regression, it shouldn't just be one variable. In fact, tí ẹ bá ń ṣe research, tí ẹ bá ń ṣe project, wọ́n máa ń advice yẹn pé kí ẹ máa lo one independent variable even though your project entirely is just talking about the impact of education on wages, but then tẹ́ bá lọ present ẹ̀ fún supervisor yóò máa sọ fún yín pé kẹ́ ẹ include more variables, so more variables that would also have implications on wages, so whether positive way or negative way, so that your work is going to be broad, so include other variables. So it may just be two more variables, it may be three more variables, but they don't want one variable because you might be attributing too much effect to that single variable, whereas there are also other important variables that you've not included in your model. So it is often advisable that you include at least three variables in your model. So in this case, a lè ní wages, a lè ní birthplace, no, a lè ní education, a lè ní birthplace. Kí ló tún lè affect wage téèyàn ń gbà náà? A lè ní bóyá a lè ní bóyá productivity of the worker. At least your productivity will also determine the amount of wage you are going to get. So productivity of the worker, then plus error term. So you can now perform the regression. Take data on each and every of these things and perform your regression. So kò ní jẹ́ kí any of these variables go overestimate the importance wọn on nǹkan tó ń ṣẹlẹ̀ sí wage. So I don't know if you got that part, so that we can delve into the limitations and criticisms of the econometrics model. Ó ti sun yín àbí? Wọn kì í get econometrics lẹ́ẹ̀kan. Wọn kì í get. Okay, okay. It's a normal thing. Wọn kì í get econometrics lẹ́ẹ̀kan. It has to be gone over like over and over. So limitations here. So since you said bí àwọn tó máa ń kọ. Okay, no. What is econometric methods example? That's the question here. Econometric method example. So I want to believe it is lean wage, B not B1, whatever, tí wọ́n kọ síbí, or the one that we did before, unemployment at a growth. I think specifying a model is what they probably mean. as um, econometric method. This should be the OLS now. Mumbo, let me check something. Method example. Okay, simple linear regression. Thank you. So the answer to that would be simple linear regression, maximum likelihood, gbogbo àwọn nǹkan tó ti dárúkọ tẹ́lẹ̀tẹ́lẹ̀, exploratory. Well, they are um, you have classical linear regression, then ó wá pín sí méjì. There is a simple linear regression, and there is a multiple linear regression. So eléyìí tá a ṣe simple máa ní one independent variable, multiple máa ní more than one independent variable. All right. So then, what are the limitations of econometrics model? Now, before even reading everything that is here, limitation number one, kò kí ń wúlò if your data cannot be quantified. So econometrics method is useless when the data cannot be quantified. So because you need to like have numbers. So for example, let's measure convenience. Ṣé you understand bẹ́ẹ̀ yẹn? So convenience is one of the factors that affect demand. Okay, as ìgbà pé convenience affect demand. The more convenient it is like access a product, the higher the demand of that product will likely be. But how would you now measure convenience? Òun yàtọ̀ sí price. Price is 2 naira, price is 5 naira. So ẹ lè kó àwọn kíní ẹ̀ pọ̀. When price is 2 naira, quantity demanded is this. When kíní kan, but kí lè fẹ́ assign fún convenience? So that's like one of the things, one of the shortcomings of econometric method. Then the second thing ni pé another well, let's read what they have. So like other forms of statistical analysis, badly specified econometric models may show a spurious relationship where two variables are correlated but casually unrelated. So another shortcoming ni pé an econometric method or an econometric model can be wrongly specified, and once it is wrongly specified, the result is going to be wrong. Mo dẹ̀ ti fi ṣàlàyé lẹ́ẹ̀kan pé you can wrongly specify a model in a number of ways. Number one, variable tẹ́ kẹ́ fi síbẹ̀ ẹ fi sí. So that will make whatever it is that you are doing, as long as that is already wrong láti bẹ̀rẹ̀, everything téèyàn kàn ṣe rubbish ni. Then number two, variable tí ò yẹ kó sí ńbẹ̀ ẹ fi síbẹ̀. Then number three, the functional relationship. So in the sense that is it that mo fi ṣàlàyé lẹ́ẹ̀kan pé wage is wage supposed to be raised to power 1, or wage is supposed to be raised to power 2, or raised to power whatever. So if you don't specify correctly, then it's going to affect your every other thing that you're supposed to like learn from it. So there's a problem. Now, tẹ́ bá ti specify model yìí, results yìí a máa pè ní spurious regression. Spurious, S-P-U-R-I-O-U-S. Spurious regression. Now spurious orúkọ ńlá ni, but kì í ṣe pé ó mean fake. That's not the meaning of spurious. Ìtumọ̀ spurious ni pé when you have a spurious regression, your regression is showing a relationship, a causal relationship between two variables where there is none. Now ẹ kì í ṣàlàyé ẹ̀. Regression lè sọ irú last year nísìn, nígbà gbogbo ìgbà tí mo fọṣọ nílé, like out of 100, let us out of 100 times, bí a mo fọṣọ ní 95 times. So gbogbo anytime tí bá ti fọṣọ bẹ́ẹ̀ òjò dẹ̀ máa rọ̀. Like that's what was happening to me like last year. So ó ti wá mọ̀ mí nílé, ẹni tí bá fi lè ti káṣọ síta báyìí, òjò máa rọ̀. Like it was that bad. It was that tójò bá rọ̀ tí bá fọ aṣọ ní ìrọ̀lẹ́, ẹ mọ̀ pé kò tí ì lè gbẹ ní ìrọ̀lẹ́, ọjọ́ kejì ló máa gbẹ. Ṣé rí ọjọ́ kejì òjò máa rọ̀ fire in the morning. So it was so bad. So irú kan bẹ́ẹ̀ yẹn sìn, èèyàn lè kó data rainfall àti data number of times tí mo fọṣọ, ó dẹ̀ ṣe regression ẹ̀, á dẹ̀ gba result tó make sense. Á sọ fẹ́ni yẹn pé 95% of the time tí mo bá fọṣọ òjò máa rọ̀. Now does that make sense? Anytime òjò, ṣó make sense? Ṣé lè fi predict ìgbà tójò máa rọ̀? So, so that's the thing. So irú model yẹn sì, irú regression bẹ́ẹ̀ yẹn sì, ó ń ṣò pé okay o, àjọṣepọ̀ wà láàrin òjò àti ìgbà tí n bá ń fọṣọ, but coincidence lásán ni. Ṣé ẹ ti understand bẹ́ẹ̀? So that's one other thing about kí ló ń pe orúkọ ẹ̀, econometrics model. So nǹkan tó máa ń pè ní causal relationship, causal meaning pé one thing is causing another thing. Irú èmi sìn, aṣọ fífọ̀ is causing rain to fall. Ṣé ẹ ti understand? But then that is not like true. Even though it may want to like make sense a little bit, but then it doesn't make sense in the general scheme of things. Irú ọdún yìí sìn, àwọn times tí mo ti fọṣọ kò rí bẹ́ẹ̀. But last year was just, it was just very very bad. Má ti kó aṣọ báyìí anytime, má ti kó aṣọ báyìí òjò yẹn ṣáà máa rọ̀, ṣáà ti mọ̀, jọ̀ọ́ má kaṣọ síta o, má jẹ́ kójó rọ̀ o, kìnìkan kìnìkan, ẹ mọ̀, that kind of a thing. So one other shortcoming of it is the sense that there can be spurious regression where your econometric model is showing you that there is a causal. Ìtumọ̀ causal ni pé one variable, the independent variable is causing what is happening to the dependent variable. So it will be establishing a causal relationship where there is none. So ó kàn lè jẹ́ coincidence lásán. So ìtumọ̀ spurious regression ni a big name for something simple. Then ó tún ní nǹkan kan tó tún máa ń sọ tó tún lè affect, wọ́n máa ń pè ní confounding variable. Wípé confounding, wípé kíyàn wà confused, nǹkan confound èèyàn. Confounding variable. Now a confounding variable is a silent variable, like a quiet variable, that is causing the relationship experienced among two other variables. So it's a silent variable. Okay, ẹ ká wo example yìí tí máa ń rántí dáadáa. Kí wọ́n porúkọ ẹ̀, anytime tí kí ṣe example yẹn náà, shark attacks an ice cream, ice cream àti shark, iye ìgbà tí shark yẹn attack yàn ó wà relationship ẹ̀ wà high pẹ̀lú iye ìgbà táwọn èèyàn ń jẹ ice cream. Àbí ìgbà táwọn èèyàn ń lá ice cream. So so irú yẹn ṣe like ẹ máa wonder, like common sense máa wonder pé báwo ni ó ṣe rí bẹ́ẹ̀ yẹn. But then there is a confounding variable there in the sense that variable tí ó wà quiet ni pé sunlight òun ni variable tó wà quiet. When the sun is shining, people feel heat and then they want to take cold things. So ó máa mú ọ lọ máa jẹ ice cream. Then àwọn èèyàn lè fẹ́ máa lọ sí beach or whatever. Like I don't even remember the example very very well. But then the same sunlight would also force sharks to swim upward. Like wọ́n ní dúró sínú omi, wọ́n máa fẹ́ wá sí òkè omi láti wá fún warmth torí ìsàlẹ̀ omi tutù. So ó máa ṣẹlẹ̀ pé àwọn tó ń lá ice cream tó ń gbádùn ara wọn àti shark náà tó fẹ́ gbádùn ara rẹ̀ lórí òkè omi, àwọn méjì máa pàdé, then nǹkan kan ṣáà máa ṣẹlẹ̀ ṣá. So téèyàn bá take cognizance of sunlight, a máa feel pé táwọn èèyàn bá fi lè ti jẹ ice cream o, shark attack máa ṣẹlẹ̀ o, àbí shark attack bá ṣẹlẹ̀ ó mì pa àwọn èèyàn tí ń jẹ ice cream. But then like that is not actually what is happening. The confounding variable there, or the confounding variable there, is sunlight, which is not mentioned. So ibi táwọn èèyàn bá ti bẹ̀rẹ̀ sí máa try àti máa ṣe investigation pé kí ló ń fà á tó fi jẹ́ pé à ń experience this kind of it, wọ́n máa pé nǹkan kan tó ń fa àwọn èèyàn wá sí, àwọn èèyàn tó ń lá ice cream tó ń fà wọ́n sínú omi láti jẹ́ kára tutù or kára ṣe whatever, òun náà ló ń jẹ́ kí àwọn sharks máa swim láti ìsàlẹ̀ òkun wá sí òkè òkun to enjoy warmth. Tó bá dẹ̀ ti pàdé ra wọn, nǹkan tó ojú èèyàn bá rí kó dẹ̀ fara mọ́. That's not the way the example goes exactly, but like I don't remember it, the exact way it is, but it's something like that, sha. So where a quiet variable is responsible for what is happening among two other variables. So if it is not included in the model, your model is just going to be telling you wrong things. And why imagine pé lọ fi irú model yẹn ṣe forecast when you've actually not really understood the cause of what is making people to get attacked by sharks. So ẹ kàn máa recommend the policy pé kó ban gbogbo àwọn èèyàn tó ń ta ice cream, àtẹni tó ń ta ice cream ní ojú títì o, àtẹni tó ń ta ice cream ní barbecue, ẹ máa ní kó ban gbogbo wọn so that kò ní sí shark attacks mọ́. But then you have not actually addressed the issue. So like something like that, sha. Then another issue is type 1 and type 2 error. You have in a study of the use of econometrics in major economics journals, McCloskey concluded that some economists report p-values later following the Fisherian whatever and neglect concerns for type 2 errors. Now there are two types of errors ní econometric research, type 1 error and type 2 error. Now type 1 error only la máa ń pè ní false positive. I will send something to you now. I think I have so here. So mo send ìkankan sí ní WhatsApp. So type 1 error ní false positive. Ìyí báyìí kò sí relationship láàrin variables tí ẹ̀ ń wò but ẹ wá ń parọ́ pé relationship wà ń bẹ̀. So instead of kó wọ́n pè ní type 1 lie ẹ wá coin ẹ wá pè pé type 1 error la máa pè ní statistics. Irọ́ lèèyàn ń pa ò bọ́ máa ní okay type 1 error ni. So for example bóyá ẹ ti develop oògùn kan tó máa cure malaria. Ṣé ẹ wá fi ṣe regression pé okay o ṣóògùn yìí cure àwọn èèyàn. Ẹ dẹ̀ wá rí pé oògùn yẹn ò cure anybody but ẹ wá parọ́ pé oògùn cure àwọn èèyàn. That's why you are making a type 1 error in the sense that there is no relationship between the potency of the drug and the cure for malaria. But you are now saying that the drug is causing malaria to decrease. So that's a type 1 error. Ọ̀làǹpẹ̀ ní false positive, that is entrance wà positive pé oògùn yìí ń cure malaria but then irọ́ ni, so it is a false positive. That's one. Then number 2 ló ń pè ní type 2 error, ìyẹn ní the reverse. Type 2 error ni pé relationship wà tẹ́ ẹ̀ ń rí báyìí but ẹ̀ ń deny ẹ̀. So you call that one a false negative. So your denial is the negativity part of it, right? And then the fact that there is a relationship that you don't want, that means it is negative. But then your denial of it ó wá jẹ́ kó jẹ́ false negative, like it is the relationship is already there. Okay, this thing and this thing are related in this way. But ẹ fẹ́ gbà okay, they are related in this way. So you are now denying it. So that's a type 2 error. So sometimes when carrying out research, àwọn èèyàn kan máa sọ pé okay eléyìí affect eléyìí. This one is statistically significant without checking the errors, the type 1 and the type 2 error. So I don't know why the material was arranged this way. Bí actually ẹ ṣe ní the hard copy material tó wà lọ́wọ́, probably they've done rearrangements in those ones. Ó yẹ kó ti ṣàlàyé àwọn nǹkan kan ká tó bẹ̀rẹ̀ sí máa sọ lórí àwọn eléyìí so that things will be easier to understand. But well, as we progress with the course, I hope that things are really going to get better. All right. So some economists fail to report estimates of the size of effects and to discuss their economic importance. Some economists also fail to use economic reasoning for model selection. So ara ìjàmbá wo ló wà nínú econometric models. Àwọn èèyàn kì í fi nǹkan tí wọ́n sọ nígbà pé àwọn èèyàn kì í fi orí pípé fi set up model wọn. So wá kàn kó oríṣiríṣi ẹ wo orú èmi sì kí n sọ pé mo fẹ́ ṣe research kí wọ́n á ní the number of times I wash clothes, máa fi ṣe regression against the number of times that rain fall or fell. Mo dẹ̀ ṣe regression yẹn, mo dẹ̀ fi ń ṣàlàyé, mo ń ṣe presentation, mo dẹ̀ ń lọ káàkiri. So mi ì fi orí pípé ṣe iṣẹ́ yẹn. So that's to tell you that regression is just all about data. Ìfẹ́ láti kó number ṣe máa fi ní result, but ṣé ẹ fi reasoning kó variable yín papọ̀? So econometric model is limited in the sense that once you just put some variables and then you just regress it, okay, this is explaining this in this particular manner, but by the time you use common sense, ẹ máa rí pé kò sí ọpọlọ pípé kankan nínú model selection yẹn. But like the model is not going to tell you. You are the one that will use your human mind as a responsible human being to tell pé kò yẹ kí variable yìí sí ńbẹ̀. So the econometric model is limited in that sense that it doesn't really help you to like tell you okay now based on reasoning kò yẹ kó fi variable yìí síbẹ̀, kò yẹ kó fi variable yẹn síbẹ̀. So that's another shortcoming. Then what else? Economic reasoning model selection, especially for deciding which variables to include in the regression. I've said that it is important in many branches of statistical modeling that statistical associations make some sort of theoretical sense to filter out spurious associations. So nǹkan tí mo ṣàlàyé lẹ́ẹ̀kan náà nìyẹn pé ó yẹ kí nǹkan tẹ́ ẹ ṣe, ó yẹ kí nǹkan téèyàn ṣe yẹ kó ní ọpọlọ pípé, ó yẹ kó mú ọpọlọ pípé dání so that a ní máa ní spurious regression, result tí ó ń ṣe pé eléyìí ní relationship pẹ̀lú eléyìí whereas coincidence lásán ni. E.g., the collinearity of the number of cage movies made for a given year and the number of people who died falling into a pool for that year. Now, regression kan leléyìí nsìn. Èèyàn wo relationship tó wà láàrin cage movie like irú Hollywood movies tí wọ́n ṣe àti iye àwọn èèyàn tó ń kú sínú swimming pool. So kí ni relationship tó wà láàrin movie táwọn kan ń ṣe on their own àti àwọn kan tó lọ ń para wọn sínú swimming pool. So it may make sense on the surface, but by the time you look at it deeply, like it may not really make any sense. Mi mọ̀ tá a bá understand the part yẹn mà. Ṣé ṣe wà ń bẹ̀ mà? Àbẹ̀ ti fi mí lẹ̀ ti leave me behind. Oh, okay. Why you to leave me behind? So second paragraph says like other forms of statistical analysis, badly specified econometric models may show a spurious correlation. Spurious let's take the third paragraph. Economists are often faced with a high number of often highly collinear potential explanative variables. So eléyìí ni pé variable kan lè máa ṣàlàyé variable míì. So ìyẹn ni mo ti ṣàlàyé pé multicollinearity. So tẹ bá fẹ́ mo ń gbọ́ra mi o. Okay, I think it's fine now. So tẹ bá fẹ́ ṣe analysis especially tí ẹ bá lo time series data collinearity máa hàn gan bẹ́ẹ̀ like ẹ fẹ́ ṣe analysis ẹ ń lo GDP per capita. Ṣebí GDP náà lọ fi wá GDP per capita. Ṣé understand? Hello ma. Okay, so mo ní èèyàn fẹ́ ṣe research ó wá lo GDP as independent variable ó tún wá lo GDP per capita. Ṣebí GDP lọ fi wá GDP per capita. So irú nǹkan bẹ́ẹ̀ GDP per capita is GDP divided by population. So GDP per capita ó sì ní GDP nínú. So ẹ lo GDP as variable kan independent variable. Ẹ tún wá lo GDP per capita as a second independent variable. So tí supervisor bá rí yẹn á ní kẹ́gbọ̀n kan yọ nínú méjèèjì. Ẹyọ kan ní kẹ́mú because multicollinearity máa wà. GDP would be àbí báwo tẹ̀ mo fẹ́ sọ ná. GDP values òun náà lè fi wá GDP per capita, so you cannot use the two. But then usually you have a lot of kí náà porúkọ ẹ̀ data bẹ́ẹ̀ yẹn especially time series data tẹ́ pé wọ́n ṣàlàyé ara wọn, so it's not going to be very easy to like separate or to like pick the right set of variables that do not show multicollinearity. So I think multicollinearity wà nínú video tí mo send sí. So if you go through it, you would understand it. All right. Leaving researchers bias to play an important role in their selection. Lena argues that Lima argues that economists can mitigate this by running statistical tests with different specified models and discarding any inferences which prove to be fragile. Conclude that whatever. Professionals properly without belief until an inference can be drawn. So yeah, wọ́n máa ní láti máa ṣe àwọn hypothesis àwọn test yẹn pọ̀ lóríṣiríṣi tẹ́ máa ṣe test for multicollinearity, test for autocorrelation, test for heteroscedasticity, ẹ ṣáà máa test for many things. Tí wọ́n bá ṣe test ẹ bá rí pé okay o kíní yìí fulfill gbogbo àwọn assumptions yìí, then you can use those variables that you want to use. But once ẹ bá ti ní pé okay GDP àti GDP per capita pé ó tẹ̀sí ló ń show multicollinearity, then that means you have to drop one of them. So the next one says econometrics is sometimes criticized for relying too heavily on the interpretation of raw data without linking it to established economic theory or linking for causal mechanisms. It is crucial that the findings revealed in the data are able to adequately explained by a theory, even if that means developing your own theory of the underlying processes. So results tí data bá fún yàn, like there is a tendency to over rely on that result. That's what this one is saying, without being backed up by a particular economic theory. Because she's something on demand and supply. Then get the results come, and then you go on and say, okay, results yìí buy. Whereas go follow theory. So sometimes it might be true, sometimes it may not be true, but they are just trying to say that here there's an over reliance on econometric results, which may not be in line with known economic theory. So like one has like really sit down and ensure that whatever one has done is like very, very correct. So that's about that part. So on unfortunately time already. So I think we may just want to like stop around here. In whatever ní ìbéèrè mà. Mi dẹ̀ mọ̀ tá a bá lè parí sí. Má mi ò mọ̀ ó ti ń ta mí o honestly. So omi kí ni ẹ̀? Mọ́mí náà máa ń sọ fún mi pé kí n máa mu omi. Mo máa ń mu omi náà like máa lọ gbé warm water kaná sí tí màá mu warm water. Yeah, yeah, thank you. Normally it is meant to be interactive but econometric nǹkan tí èèyàn ṣe mọ̀ tẹ́lẹ̀ ló máa ń wà interactive sometimes. So irú nǹkan báyìí ń sìn. So I don't know. Is there a chance that we could meet tomorrow, or because more okay you would likely have to go through those videos and then go through the recording of this one. So will you be able to like go through all of them and then we meet tomorrow? Because nǹkan tá a bá tún ṣe é ṣe máa tún build lórí eléyìí tó ti wà lẹ́nu. All right, no problem. So I'll work on this. I'll work on this and send it across to you. All right, ma'am. Yeah, welcome, ma'am. By God's grace, I mean.